So it is actually very very easy. We are solving mock 26 question 3. Suppose we have we may given with many different types of portions. They are generating their own forces, right? And their directions can be different. For example, suppose this is your reference line. So mostly we used to calculate lift force, right? Because that is produced by the wing. Okay, so see, we say lift force. So why we are saying lift force? Because a force which is lifting our aeroplane, correct? That's why the name is lift force. In same way, if you have a vertical tail here, so when the air will hit like a vertical tail, even this vertical tail is nothing but a wing, right? But it placed vertically. So even when this wing will experience some kind of air, even this will generate force in this direction, correct? Because all the wings used to generate force perpendicular to their plane form area, correct? So like here we have wing here, so this wing is generating our lift force. In same way, this wing is here, that is we are saying as vertical tail, that will produce a force perpendicular to its own surface area. So that symbol can be anything. Don't go on symbol, just go on the feelings, right? So why this force is this force symbol we are seeing as, and popularly we known as lift. This known as lift. In same way, this force, don't, if you don't want to give any name, you just give some symbol Fy, correct? Why I'm saying F means force, why? Because this force happens on y axis, right? This lateral axis, like this axis we say as y axis, correct? Now you see, if this much force will act on this wing, then how will you calculate the formula of force, and after that how will you calculate the moment generated by this force? So first you understand the concept of moment. Concept of moment is very simple, and it is valid for all kinds of forces. Suppose you have aircraft here, and this is the CG of aircraft. You are getting one force here, then this will be your perpendicular distance. You are getting one force like this, so this will be your perpendicular distance, right? I mean, based on the force and the perpendicular distance, aircraft will rotate in that way. So this force will rotate the aircraft like this kind of situation. If this is the nose and this is the tail here, then we say pitch up, correct? And if the same force is below, then pitch down by using same moment. And if this tail is acting a force here, I mean, if there is a force acting on the tail in this direction, then this will make aircraft to turn like this. So it is kind of yaw, right? Now, I mean to say that the way we calculate lift, in same way we will calculate this force. Only the sense is exactly same. Only the idea is exactly same. Only location is different and names are different. See, how do you calculate lift? Half rho v square SCL. Okay, now understand this property wise. This is dynamic pressure. This is planform area. What is this? This is dynamic pressure experienced by the wing. Whatever wing we have here, that wing, how much dynamic pressure is experienced by the wing. So rho means what kind of fluid is reaching to the wing, density of the fluid. Then what is the velocity experienced by the wing? That velocity you keep here. What is the planform area of the wing? And in the last you will substitute coefficient of the particular force which is being produced on the wing. But we are producing lift, so we are saying CL, coefficient of lift. In same way, if you are bothering about this force, suppose this is a reference line and here you have tail, and tail is producing some force here, that I am saying as Fy. So even for this force you will be having some coefficient of force, right? Cy, I am saying as Cy. So when you will find out this force Fy, then you will write again same dynamic pressure, and then planform area, and then coefficient of force. That's all. Dynamic pressure can have formula half rho v square. Okay, but now you make sure which row you will take, what kind of fluid is coming here. So on the wing and on the tail, air is reaching. So rho will be same here and also and here also. It's not like your air is being converted into oil, correct? So rho is here also and rho is here also. I mean to say that what is the density experienced by this tail, that density matters, right? In case of compressible flow, maybe this density and this density will not match. Okay, so now idea is what is this velocity? So the same logic. What velocity is experienced by the tail, correct? That velocity will substitute here. And but in the question, dynamic pressure was given directly, so no need to bother about these two terms separately. Okay, now what is planform area? Given directly. Now what is Cy? I explained. For every force we have its coefficient of force, right? In case of lift we say this coefficient of force as Cl. Okay, now by using these three multiplications you can find out your Fy. After that, once your Fy is done, then you can see here I explained here, when the force is acting you multiply with the distance with Cg. I mean to say that fuselage reference line, here suppose you have CG and here you got your tail, and tail is producing some lift here y, and this is distance because of this distance only your Fy will produce moment here, and that will be yaw in nature, correct? What kind of moment it will be? Yaw. In aviation we say this moment as yaw, correct? So multiply this distance with the force, you got it. Okay, you got the moment, and symbol we give n. So n is equal to Fy into the that we say as arm length, correct? Lt. But if you are using vertical, then you can put symbol Lv, correct? That's all. We got the answer. Multiply all the terms given in the question.